So here we have triangle ABC, and they're telling us that AB is congruent to AC, and that angle A is 36 degrees. And they're telling us that point D is on side AC such that BD bisects angle ABC. So this angle is the one getting bisected. So we cut this angle in half, and wherever we land, and we call that point D. And we know that these are going to be the same. Now, as a matter of fact, before we did that, you know what we could have done? The original triangle ABC is isosceles because of these markings. So that 36, so 180 minus 36 is 144, and 144 divided by 2 is 72. That means that this is 72, and that means that this whole pink is also 72. But since this angle is being bisected, we can turn this into 36. Maybe we can separate these triangles. So I labeled the vertices ABD, ABD, D's, B, C right there. I copied and pasted the angles. Now, let's see. So we know that in a triangle, we have 180 degrees. 36 and 36 is 72. 72 from 180 means that this is 108 because the angles have to add up to 180. If you add these up, that's 108, which means this is 72. This triangle here, it doesn't look it, but it's actually isosceles because that 72 is the same as this 72. And if these 72s are the same, that by the base angles theorem, the converse of the base angles theorem, that means that those two are the same. So here we have that BD, this guy is the same as this guy, which is BC. But then look over here. If these 36s, see that 36 and 36, those match, then that means that this is the same as that. So that would tell us that BD is the same as AD. So really, BD is equal to itself, obviously, and so BD equals these guys as well, and so we can conclude this. By transitivity, we have shown that this statement holds true, and that was actually part A. So BC is X, and then they're saying that CD is Y, so CD is Y. According to part A, BC is the same as AD. So BC is called X, then that means that AD here, that can also be called X. Now, for part B, they're telling us that these two triangles are similar, and that is true because if you orient them accordingly, the whole original triangle is here, and this little guy has been rotated and placed here. Notice that all the angles are congruent, so these are in fact similar. And it seems like this guy is a smaller version of this. Now, what can we call the sides? Well, look, AC is all of this, so I need an X and a Y. So this should be called X plus Y. Down here is just X, so that's X. And now BC, they said that BC is X, right? So this here is also there. BC is BC, so that's X. And then what else do we know? How about this here? We know that BC is the same as BD. And so BD should also be called X here. And then we know that they're telling us that CD should be Y. That's part of the given for part B, that this is Y. And if you want, you can just copy and paste the X plus Y there as well, because this triangle is isosceles because of the 72s. Now, we can create a proportion, a statement that says like, this is to this as this is to that, or this is to this as this is to that. It doesn't matter how you build it. Just build something that's true. How about we go, this is to this as this is to that. So X plus Y, that is to that, as this is to that. So here is an equation that relates X and Y. They wanted us to write an equation involving X and Y, and so we have. I don't know if this is as much as they want. If you want, you can cross multiply. And if you cross multiply and experiment with the terms, you can get this as well. I don't know what's better, but let me just leave it to you to decide which of these is better. And as a matter of fact, any variation of this could have been true. For instance, this guy here, if you turn that upside down, that also would have been an equivalent equation. So all of these are acceptable answers. It doesn't matter which one you turn into them, it'll be true. So that's parts A and B. Now for part C, they want us to let R equal Y over X. So why don't we go to this equation and let's write this down again down here. Why don't I turn this upside down, but because I've reciprocated it, I have to put it to the power of -1. We do this. Why don't we actually split this up? Okay, so I separated that into two terms, no harm, no foul. X over x is just 1. Now we can use the substitution because y over x is the same as r according to part C, so that and that can become r. So we cross multiply, we get this. Now let me bring the 1 to that side. Now what I want you to see is that this is a quadratic equation where 1, 1, and -1 are the values of a, b, and c. Now we can go quadratic formula to solve for r. And if you go quadratic formula, this is what you get. So these are the two potential values of r. But because r represents a ratio of two sides that are not negative, this number is negative, it's thrown away because it's negative. And so r is equal to this here. So let's just write this down again and declare this to be the answer to part C. Now for part D, I want to remind you of the law of cosines. This is a variation of the law of cosines. A is the angle that you want to find. Little a is the side across that angle. And B and C are the sides of that triangle. So if we go back to our original model, how about this one here? This is the original triangle. Let's make some changes. So instead of A, capital, we're going to use 36. Instead of little a would be across angle A. Little a is going to be x. B is going to be across B, which is that. And C is going to be the side across angle C, which is x plus y. So let's make all those changes here now. The goal is to find the cosine of 36. That means we have to clean up all of this mess. So here's what we can do. So that and that is the same thing, so I have two copies of that. That and that are being multiplied, so that's squared. That was the tricky part. So I removed this factor from this term and from this term. And here's what I'm left with. And I know this is correct because if I were to distribute this back in, I would get back the previous. Now, let me divide by this. And because this and this are being squared, I can actually turn those into one piece. Merge these together into one, and I kicked out the over 2 as a 1/2. Now, let me turn this upside down and call the 2 a negative power. Now, the reason I turn this upside down is because now I have the ability to take this one fraction and to separate it into 2. So this is what I have. Now, instead of y over x, remember that y over x equals r, and that according to part C, r equals this. So let me take this fraction, which is r, and drop it in right there. Now, this one here is 1 over 1. So let me multiply by 2, top and bottom, to get a common denominator. And let me actually turn those into one fraction. I got a common denominators. I merged the two numerators into 1. Now 2 minus 1 is just 1. Now we can't have a negative power, so let's actually turn this back upside down to make the 2 positive. Now I don't like how the bottom has a fraction, so what I'm going to do is I'm going to multiply bottom and top by the conjugate. 1 minus square root 5. 1 minus square root 5. And this is what you get if you multiply these and multiply those. In the top, I decided to leave it 2 times that. And in the bottom, if you go this times that, and if you distribute it, some teachers call it FOIL. Really, if you just distribute, you're going to get back -4. So I squared the 2, boom. I squared that, boom. And I squared the binomial, and this is what I got there. Now let's just clean these things up here. Let's see. So that reduced with that to get that. And here, 1 plus the 5 gave us a 6. And how about we just call that an 8 in the bottom? Let's see. So I've cleaned up quite a bit. Let me subtract 1 from 3/4 to get -1/4. Now, all of these terms are negative, so let's actually divide by -1 to make them all positive. And so as it turns out, this here is the exact value of the cosine of 36.